How cold was ancient Earth? Snow fell for billions of years. The entire planet was almost covered by ice and snow. The ancient continent was the location of Earth's third evolutionary era. This entire process took about 2 billion years. What did Earth experience during this time? Around 2.5 billion years ago, a single-celled microorganism known as green algae began to appear on Earth. This organism had the ability to photosynthesize, an extraordinary ability to produce oxygen. For a time, they thrived on Earth and produced vast amounts of oxygen, triggering the famous Great Oxidation Event in Earth's history. At this point, greenhouse gases such as methane were gradually replaced by oxygen. Oxygen levels soared while greenhouse gases were slowly diluted. The global climate began to cool, and polar ice caps gradually formed. As ice expanded, the albedo effect emerged. White glaciers and snowy areas reflected sunlight back into space, preventing heat from accumulating in the atmosphere, causing the Earth to cool further. Soon after, northern and southern glaciers began to spread. The equator gradually froze, and the entire Earth was covered by glaciers. The albedo effect created a vicious cycle. The more ice there was, the more sunlight was reflected, and the colder the climate became. Earth entered a long glaciation period, also known as the Snowball Earth period. This period was not continuous. It lasted about 1 billion years. Despite the extremely cold surface, the area beneath the ice remained warm. Near geothermal vents at the bottom of the sea, some microorganisms survived and even thrived. This allowed life to persist during this freezing period. If Earth was to escape this frozen state, volcanic eruptions alone may not have been enough. External forces were needed. Around 1 billion years ago, an asteroid named Pengu, traveling at a speed of 64,000 kilometers per hour, approached Earth. The heat from the direct impact caused the ice to boil and produced significant greenhouse gases until the global ice melted. Shockwaves from the collision led to the division of Earth's continental plates and the creation of a new continent, Rodinia, the prototype of the later Pangaea supercontinent. During this period, mountains, rivers, lakes, and oceans were formed. Our Earth was about to enter the next geological era. Around 540 million years ago, new life began to develop. The emergence of this life is known as the Cambrian explosion. Remarkably, we are living in this geological era today.